We are looking to enhance the top Trumps project from the YByte Python curriculum available at www.ybyte.in. In fact, in the last video, we saw how we can create a kind of training for our player, which, during which we tell the best card from every category to the player. And that's interesting because that gives some insight, onto the player on how he could potentially play this game. So for example, we are showing the best card for built up area, best card for time to build and so on. In fact, we can go further and provide more information to our player as part of the training. We can say that, look, along with the best card in that category, I'll also tell you the next five cards. So basically, I'm telling, for example, the top six cards for height. Again, six is just a number. We could choose to give top three cards, top seven cards, top eight cards, whatever, but we don't want to give too many because otherwise, too many things to remember. So here I'm giving six cards for height. So Burj Khalifa is a number one, Freedom Tower is a number two, and so on. Next, I, give, let's say, six top cards for floors. So again, Burj Khalifa is number one, but interestingly, Freedom Tower is no longer number two. Notice Freedom Tower is somewhere here. If I keep going, so it tells me six cards for year built. Notice best is Leaning Tower of Pisa, as we knew earlier or two, built in 1373, and the next best is 1888. So a big jump from there, and that happens to be, let's say, Parliament House in London, and so on, right? So it tells me, look, built up area, top six cards. So then, for similarly, like I have top six cards for the time to build. Now, clearly, this is giving a lot more information to the player. The training is hopefully much more useful because it's providing a lot more insight into the cards. We are going to build this feature in this video. But one thing to realize before we start is that all of this information, in fact, is available to us even when we are finding the best card. Now, what do I mean by this? Recall previously we did this, display of the best card, and at that time we sorted this list of dictionaries, the list of cards, using a specific metric. So, for example, when we were looking at, let's say, height, floors, and so on and so forth, we basically took that value and we sorted this. So let me just, for the sake of illustration, let me put let's say, a print, let's say all cards S over here. Now keep in mind that this all cards S is inside a function, which means I won't be able to access it outside. So that's why I'm just putting a print over here, and I'll in fact put an input just for, let's say, just to kind of pause the game here. So when I run this, it asks me if I want a training. Yes, I do want a training. You notice that I have printed now notice it has printed this all cards S, which is a dictionary which has been sorted in an increasing order of the height. That's why the building on top here has a height of 186. That happens to be Leaning Tower of Pisa. If you keep going down, you'll see that the last building is indeed, Burj Khalifa, which is 2717. Prior to that, I have, let's say, this building here, height of 1776, and so on and so forth. So the point I'm trying to make is that, in fact, this information is already available to us. It's just a matter of then reading more entries from this sorted list. So that's what we are going to do at a high level. But then there are some very unique challenges which we must encounter, which we must, let's say, solve for this feature to work correctly. So I'm going to, for now, let's say, disconnect. Rather, let's say, remove those two lines because I don't want that. I don't want to disturb this function. So I'm going to define a new function called, let's say, display top cards. And, of course, these cards must be by a given category. And I want to display, let's say, n of those. So for example, n could be 5, 6, 10, whatever. So top 5 cards, top 6 cards, top 3 cards, and so on. So that flexibility is available to me. Now, basically, I'll just put a small comment here. Display, let's say, not the best card in every category. Let's say display the let's say the top, say, n cards in a given category. So that's what I'm. Now recall that the definition of best card depends on what category we are looking at. In case of, let's say, for example, floor, height, and so on, the best card is the biggest. On the other hand, in case of year build, it's exactly the reverse. The best card is going to be, let's say, the one which is has the smallest value. For example, 1373, or, for the Leaning Tower of Pisa. So which means that I need to handle these two cases, kind of like what I was doing here. In fact, I'll just take exactly this piece of code. For now, actually, I'll take, let's say, all of this because I need to use that sort of statement later on. So I'm just going to say, look, let me, let's say, indentation is important here. So I'll just ask myself a question. Am I looking at, let's say, the cards which are, in So I'm going to ask myself a question. Am I looking at a category? So this has to be category. Be careful with these small, changes can cause a lot of problem. So this has to be category. If this category is in, let's say H, F or B, well, it means higher the better. I'm going to sort the cards, all right. So this, I'm going to create a new sorted list of dictionaries. So let's just use this itself. So Control C this and put it here. So do it slowly, do it carefully. So I'm going to, let's say, all right, so the indentation has to be correct. Yeah, so all cards is sorted. I sort all cards. Now, in this case, the category has to come from category, right? So category, and I will intentionally do this in a reverse order. Now we'll talk about this. Remember, reverse equals to true means this will be placed in the descending order, which means that the top card here will be the one which is the biggest. And I'm doing this intentionally. We'll talk about this later just to keep the code simple. On the other hand, if I have the other two cards, I will in fact arrange them in an ascending order. Now again, this is being done with some intention because kind of keeps the code somewhat simple. But the important thing to understand is that look, all cards S in the first case would be, let's say, in a descending order. All cards S in the second case would be in an ascending order. And the key of interest is basically category. So I'm just kind of sorting out this entire, let's say, list in a certain order. But now comes a very interesting challenge which we must understand beforehand before we start writing any code. That we want to make the display a bit more tabular so that's a bit more concise, like what we did in the laptop store project. But the challenge really is that there is a lot of variation in the lengths, both of the keys as well as the value. You can clearly see that this key is the longest key, and sometimes the key itself is, for example, in here, this key is, the length of the key is shorter than the length of the value. So if I want to put this in a tabular format, I need to somehow account for this. Otherwise, the tabulation does not look nice and it's not so clean as if you would like. So what we need to do really is that we need to somehow create unequal column widths. Every key should have a different column width. And the way we would do it is that we'll find the column width to be the max of the length of the key, which is the column title, as well as the length of the longest value in that key. Let me just try to explain what I mean here. In case of a built up area, essentially, we are just saying, okay, let the column width be as long as much as needed to say, accommodate this entire key. However, for building name, notice the values are likely larger than the key itself. So we are going to say, let's just make the column large enough so that it can accommodate this entire name. So kind of a mix of both. We are going to say, let's find out the length of all the keys. Let's find out the length of all the values and find the max of those and make the column width around there. So that's the sort of the thought process. We'll do this step by step in code. Quite interesting. Now you might be wondering, why do I need to do all this? Because I already know that the longest key is this, and very likely the longest value is, let's say, one of these countries, right? So why can't I just fix this? But I thought keeping the code a bit flexible, one, keeps it flexible, so which itself is nice, and two, it allows us to sort of learn some concepts in a nice way, which could then be useful. So this is what we are going to do. We are going to find out, the length of all the keys, and this can be done through list comprehension. And then finally, we are going to find out the length of longest values in every key. So we can make use of sorted function again. Like I said, nice programming practice as we do this, right? And finally, we'll take the max of both to become the column width. So let's, get onto a project and do this here. Basically, remember, all cards S is a list which has been list of dictionaries that has been sorted basis that key. Now I'm going to find length of all the keys. In fact, I can do that by saying, okay, look, so be careful with the indentation. So keys is, let's say, list. I'm going to find out all the keys of this card. So all cards S or all cards doesn't really matter. I can look at 0 because the keys have not changed. Dot say keys. So basically, I'm getting essentially all the keys. That's basically what keys is. Now I'm going to find out the length of each of these keys using a list comprehension. List comprehension, remember, is just like a for loop. So I'm going to say keys len is equal to, let's say, len of say key for key in let's say keys. So basically this is going to tell me, look, what is the length in characters of every key. Now I want to find out remember the longest value for every key. Now this is a little bit interesting. Let's pay attention to this. So I'm going to create, so let's just also create length of the longest value. Length of the longest value in every key. So I'm going to say, look, you know, let us make a new, let's say a list here. Let me just call it, let's say longest val, and let this be an empty list. Notice square brackets will always make it a list. So this is a list. Now I'm going to go through all the keys. I know the keys from here, line number 25. So I'm just going to say for k in keys, well, basically go through every key. I am going to do something very similar. I'm just going to sort this whole dictionary. Um, Actually, we'll use this. I'll use this. Now, not to be confused, I am not sorting it from the value point of view. I am sorting it from the length of the key. From the length of the given category, right? So I'm going to say, look, for K in keys, um, let me sort out all cards. Key here would be, let's say, not float, but in fact, len of, let's say, x. And so once I do this, my all cards D will be a new sorted list where the sorting would have happened basis on the length of the value, let's say, corresponding to key K. A little, go slowly so that you understand this, right? Now, how do I find out the longest key? Well, all I need to do is to append, let's say, the length of that particular attribute. So let's say length of all cards D, say -1, and here it is K. So again, look at this carefully. Remember, all cards D is a list whose items are dictionary. So I'm basically saying go to the last item, look at this particular key, which is K, and find the value of that key. That must be the longest key, because the longest value in that key, because we have done the sorting basis this, right? So think through this carefully if you want to get print all cards D to kind of get an idea. Now, before moving further, let us try to understand what is going on in this code, because lots of things happening. It can get quite confusing. A little bit hard to probe this because these are all inside a function. However, to make my point, I have put some print statements. So I'm printing the keys. I'm printing the keys dictionary. The I'm printing here, and then I'm printing the K, which is the keys inside this loop, the list all cards D, the sorted list, and also this longest val. So I run this piece of code. I just go and directly run my function. Let's say I want to do this. Tell me display the top cards for height, and let's say 5 of them. Right now, obviously, that is just 5 is not being used. So I just first get all the keys as we know, and then these are the lengths of those keys. So basically, like the building name is 13 characters, country is 7 characters, and so on. Clearly the one that wins all this is 28 characters in the built up area. Next, remember, as part of this loop, we go and sort the dictionary all cards again by the length of that value. So notice first I'm going to do for building, and you see what happens here. The first, the longest name of the building is this one, Trump International Hotel and Tower, Chicago, Illinois. This is the longest name, and hence this has come on, on top, as basically as the last item of that list. The longest value is now 47. So what I mean is that, look, for the longest name of a building is basically 47 characters. Next, I get 47 and 20. So what I'm saying is, look, the longest country is United Arab Emirates, and hence the longest country value is of 20 characters, and so on. So once I run this, I have the longest key and the longest val. Now my goal is having these two lists, which is the key list, the keys length, which is, let's say, this list, and let's say this list. I want to find out a third list, which is maximum of both of these. So in, let's say, in the category of, let's say, the building name, we will go with 47 characters. On the other hand, in the built up area, we will go with, let's say, 28 characters. So max of both of these. The way we can do this, I can give you an example here so that becomes more clear. So I'm just going to say, let's say we have two lists over here, 1 2 3, say 5 6. Let's say 1 2 3 6, and say 9. And I have another list here of equal length, which is, let's say, 2 1 2 3 1, say 8 and 7. um, Now I want to find out what, item by item, what is the max of these two. Of course, I can run a for loop, but a more concise method comes by using what is called a zip. So I can just go and say, well, look, let me zip up these two items together. This basically creates a tuple, and we can see this by converting this again to a list, so that becomes a bit more clear. When I do this, you notice my C has become tuples: 1, 2, 2, 3, 3, 1, and so on and so forth. Every corresponding item has been sort of zipped together as a tuple. Now, clearly, I can find the max of all this by just running a list compression or a for loop. And I can go and say, well, so let's say, let's just call it, say, C max is equal to, say, max of M for M in C. And I think that should really do the job for us. When I do this, notice I have got 2, 3, 3, 8, 9. That's because the max between 2 and 1 was 2, 3, 3, 8, and 9. So this is the idea that we are going to use. I can just go and put this in my code now, basically having sort of obtained. So I'm going to remove these prints. Um, Again, play with this, spend some time with this so that understand all this better. The sorted function is really powerful actually. So I'm going to say, look, having obtained the keys length and the longest val, let me find out the maximum between these, because that's going to be my column width. So I'm just going to say, let's say max call is basically, say, zip, say keys, say keys length, and say longest, let's say val. And I'm going to just find the max of all this by just going to say list comprehension again. So max, say M, um, for, say, M in max call. Now think through this carefully. Really not too hard. I'm just trying to find out the maximum width of the column for every given category. And once I've done this, in fact, the job is almost done, because remember, this is now just like laptop store, except that in laptop store, my column width was fixed. But here, my column width is no longer fixed. In fact, I'm going to, print every column with a different width. However, the values that I'm printing are more interesting. Remember, I want the 5, let's say, best cards for every category. Now, keep in mind, the first 3 categories, which is height, floor, and built up area, larger the better. Notice, however, I have sorted this list in a reverse order, which means that the best cards are in fact on top, because this is a descending order. So best cards are on top. Likewise, for this guy, I have not inverted the order, which means the best cards are still on top, because for these guys, lower the better. So which means, and this is how my code remains homogeneous. I can go and say, look, let me print this thing out. First, I'll print all the keys. So again, this is something we have done before in the laptop store, for instance. So I'm going to say for key K in, let's say, all cards S, say 0. So basically get all the keys, so print. So this is basically printing the keys, say, n equals to, let's say, apostrophe. And then I print, the right number of, let's say, spaces, right? So essentially, previously we had taken, let's say, max characters or something like that, when we printed the display card. But here's something similar. I'm just going to get max call, which itself is a list, remember. So I'm going to find out which item it is, that I'm looking at. So I'm just going to say k dot index, say k. Again, think through this carefully. It's not hard, but it does require thinking. Minus, say, length of, say, k. So I get this, and I print basically this many. Okay, so I have to be a little bit careful here. I'm going to print, let's say, this many spaces, right? So this has to be a space here, with a single space. And of course, the end can then be put to anything. So I just go and put end equals to, let's say, a vertical line. And I can end my print statement here. I can put a single print outside this. Next, having printed, so let's say print the keys. Say print the keys. Here I can put max column width for every key. And then now having printed the keys, now it's time to put the values. Values are basically coming as items from the from the list all cards S. So I'm just going to say print the values. Clearly, this has to be a double loop, a nested loop. So I'm going to say for card in all cards S, 0 colon n colon nothing. So basically, I'm going to print the top n items from that list, because as we discussed, those are the items of interest. And then this has to be inside another loop. So I just going to say for k in, let's say, card, So basically I pick up the card in all cards S and for K in card. So now this inner for loop is running over a dictionary, exactly same as like our, our, let's say, and I need an indentation here as well. So basically I'm going to print not K anymore. I'm going to print in fact card K. And again, here it is not length of K, it's in fact length of card K. And this print has to be inside the for loop because after printing one card, I must give an empty, let's say, print so that I come to the next row and then I print the next card and so on. Exactly same as what we are doing in the laptop, except that now my max calls is a function of the key. So we can see this working, if I just did Control C, if I just, let's say, displayed top 5 cards for the height. In fact, that's how they are. Burj Khalifa, Freedom Tower, and so on. Nicely formatted, looks really nice, easy to read, and so on. Now, having done all this infrastructure, all the, let's say, the inner part of the code, in fact, we can now go and enhance our, training function. I can just go and say, look, let me get to my training function. So I already have this function which does the, let's say, the heavy lifting for me. Having displayed the best card, I can go and say something like, let's say put another print here, and I can go and say, well, n equals to, let's say 6. So I want perhaps 6 values coming back. And I can just go and say for k in relevant keys, I can then just go and say put a print here, put, let's say print, say top, n cards for say K. So for every category, I have these top n cards, and I can display my top cards over here, right? So I just say K and say K and N, and I can give an input here for my player to sort of scan through this, right? So I'll just put, let's say, one comment over one print over here. Let's just put, say, print more training, more training, so that it's clear that we are moving to the next training. Let's, maybe 6 is too much. Let's just say we get top 4 cards, something like that, right? Now, when I run this, so again, I click enter to begin. Yes, I do want the training. So remember, first it shows me all the best cards. It goes in some detail. In fact, now we can even think of skipping this step. I can just go and say, look, show me the top 4 cards for height. So those happen to be Burj Khalifa, Freedom Tower, Taipei, and so on and so forth. Next, top 4 cards of floor. Notice again, Freedom Tower was there in the top 4 cards for height, but not in top 4 cards of floor. Top 4 cards for year built. Notice the order has been reversed, but I'm getting it correct. 1373 is the best card for me. Lean Tower of Pisa, Chrysler Building, not bad. 1930, right? So it gives me an idea. Then I have top 4 cards for, let's say, the built up area, and top 4 cards also for time to build. So very interesting, how the data is being, let's say, assembled to present in a nice, clean manner, right? Just a couple of changes I will make. I will, in fact, say, well, top 4, let's say, cards for, let's say, for every category. And when I'm asking for training, I think there's a small little, let me just cover this as well. And let's say make a backslash n over here. But these are all cosmetic. Uh, uh, this has been a long video, but I hope this has been useful to you. Lots of interesting programming concepts putting together to make something work. So this is the style of learning programming at Byte. Build activities, because that is when we apply concepts. That's when we challenge ourselves to make things better, and we learn that much better. Take a look at our website www.ybyte.in. You'll find that there are many such activities through which we learn Python programming. Take care. Thank you so much. Bye bye.